So welcome to 6.7. So this is our third day of learning the elimination method. And so far we've had ones where we didn't have to do anything to the equations. We just added or subtracted them together and they magically had an elimination. And then in the last lesson you had to multiply one of the equations. Well, what's left? Where you might have to multiply both equations. So let's remember how to do this. Right? We're looking for things that are the same coefficient or opposite coefficients. And so I'm looking at the y's and I'm saying if I multiply this bottom one by 2, I would get 4x minus 2y equals 18. And notice I'm going to take the top one and I'm just going to write it right underneath. There is no magic to which one is on the top and which one is on the bottom. So, oops, I just messed up. Wow. Hopefully you all caught that because I'm multiplying the bottom one and I was thinking about what I was doing next. 2 times negative 2 is negative 4. The 18 is with this equation, the bottom one. All right, I just moved that there. So then I can add them together and I get 7x plus 0, negative 4 plus 18, 14. Divide both sides by 7. X equals 2. That's the x coordinate of where those intersect. I'm going to put that in the top one. 3 times 2 plus 2y equals 18. Subtract 6 from both sides. 2y equals 12. Divide by 2. Y equals 6. And these two lines cross at 2, 6 right there. So, solve systems by multiplying both equations to a force elimination. So let's look at this, right? There's nothing, right? I have a 4 and a 6. So there's no way I can turn a 4 into a 6. I could multiply by 1.5 but that's not really a good solution to that, right? And there's no way I can turn this negative 4 into that 5. So what could I do? Well, there's many things I could do. Let's see, I could multiply the top one by 3 and the bottom one by 2, right? Because then the top one would become 12x plus 15y equals 18. The bottom one would become 12x minus 8y equals 4. And then notice, so what did I do? I turned both 4 and 6 into 12, right? Alternatively, maybe I could have done something. Can you think of something else I could have done? Well, I could have multiplied the top one by 4 and the bottom one by 5. Let's look at that. I could have made the top one 16x plus 20y equals 32 and the bottom one 30x minus 20y equals 10, right? I turned both the 4 and the 5 into 20. Okay, right, and so in this case you would add the two equations. Either would work, so let's see that today. All right, so pick one and solve the system. So the one possibility is to multiply the top one by 3 and the bottom one by 2. Why did I choose that? Because I'm going to turn both of those into 6's. And as long as I do everything to both sides, this will work. So 6x plus 12y equals 18, 6x plus 10y equals 16. They're the same, so I'm subtracting, right? So 0, 12y minus 10y is a positive 2y, 18 minus 16 is 2. Divide both sides by 2, y equals 1. Remember, you're not done. That's the y coordinate. The x coordinate, I'm going to put it in the bottom one. And by the way, you can put it in any of the 4 equations. There are 4 different equations here, right? The 2 on the bottom, though, are equivalent. The 2 on the top are equivalent to each other. So it doesn't matter. And so I'm going to subtract 5 from both sides. 3x equals 3. Divide both sides by 3. And x equals 1. I can't make it easier than that. 1, 1. Let's try another. Right, so what else could you? You could have multiplied by 5 and 4 as well. All right, so you have choices here. So since we did x last time, I'm going to do y this time. All right. Now I could have I'm going to multiply this one by 3. So I could have multiplied this bottom one by 4 or 2. Either one will work. And let's see that. So the top one, I chose 2. 12x minus 6y equals 18. Negative 6x plus 6y equals negative 6. I'm adding the two equations. 12x plus negative 6x, 6x. Negative 6y plus 6y is 0. 18 plus negative 6 equals 12. Divide both sides by 6, and x equals 2. So the x-coordinate is 2. I'll put it in the top. 4 times 2 minus 2y equals 6. Subtract 8 from both sides. Negative 2y equals negative 2. Divide both sides by negative 2. Y equals 1. And realize that, if you eliminate a different one, I got x first and y second. But if you do the other one, you get y first and x second. So I made both of these into 6, right? But I could have made both of those coefficients of x into 12. Could have done that. So let's just do 5 for the bottom and 2 for the top. Get them. So I'm going to make 10x's there. 10x plus 8y equals 2 times 8 is 56. We get 10x on the bottom minus 15y equals 10. I'm going to have to subtract. So I get 0. Now, some people, as I've said before, don't like to do the minus version. And you could have multiplied the top one, say, by negative 2 and avoided, and then you would have added them together. So, but 8y minus, right, it's 8y, sorry, 8y minus negative 15y. That is 23y. That looks, is it 23y? And equals 56 minus 10, which is 46. I was like, why is this not coming out nicely? I'm not usually this mean. Well, yes, it does come out nicely because 46 divided by 23 is in fact 2. And so then 2 goes in for y in either equation. I picked the bottom one. It really doesn't matter. Negative, that 3 times negative 6, so I'm adding 6 to both sides. 2x equals 8. Divide by 2. X equals 4. They intersect at 4, 2. This one's not lined up. You need to rearrange. Okay, so the top one is almost in standard form, right? It's got a negative a, but it's fine. And then I'm going to subtract 4x to both sides here. So negative 4x plus 5y equals negative 30. So then I am going to multiply the top one. I'm going to multiply the top one by negative 2 just to show one like that. Okay. So if I multiply the top one by negative 2, it becomes 4x minus 30y equals negative 20. And because I did that, I get to add the two equations. And as I said in the last lesson, some people like to always add. 4x plus negative 4x is 0. Negative 30y plus 5y, negative 25y. Negative 20 plus negative 30, negative 50. Yeah, when you're adding these together, you're less likely to make a mistake, I think. Negative 50 divided by negative 25 is positive 2, so the y-coordinate is 2. And again, you can put it in any equation up there because the bottom ones are equivalent. They're the same exact linear function. And we're finding where the two linear functions have the same exact x and y coordinate. So let's just put it in this one right there, just to be different. All right, 5 times 2 equals 4x minus 30. Add 30 to both sides. That's 10, right? So 10 plus 30 is 40 equals 4x. Divide both sides by 4. 10 equals x. And so these two linear functions intersect at 10, 2. Okay, so we're going to, oh my goodness, we're going to clear our fractions here. So pause the video and try to clear the fractions and then the decimals and see what you get. Well, I've got to clear 2 and 3. So what do you multiply by to get rid of both a 2 and a 3? It's got to be something on the 6 times table, right? Because that cancels that 2, that cancels that 3, oops, this is a 2 there. And so you get 3x plus 2y, 6 times 0 is 0. Right? To clear there, we have to move the decimal twice, and so we have to move the decimal twice everywhere. So it's 10x minus 18y equals negative 74. Okay, so now what am I going to do here? Well, I'm going to multiply the top one by 9, I guess. I guess that's what I'm going to do. I'm going to multiply the top one by 9. And so I get 27x plus 18y equals 0. And then I have 10x minus 18y equals negative 74. And then I'm going to minus 18y. We're going to add them together. And I get 37x plus 0 equals negative 74. Divide both sides by 37, which would be hard, but it came out very nicely. 37 goes to the negative 74, negative 2 times. Now, again, remember, I can pick any of them. So why would I pick the ones with fractions and decimals? Why don't I pick this one right there? So 3 times negative 2 plus 2y equals 0. That's negative 6, so I'm going to add 6 to both sides. 2y equals 6, divide by 2, and y equals 3. So these two lines intersect at negative 2, comma 3. That is the solution. Okay, so I have a little problem here with technology. There we go. So what are we going to do here? Let's multiply the top one by 3 and the bottom one by 5. So the top one becomes 15x minus 30y equals 15. The bottom one becomes 15x plus 20y. 5 times 23, that's not the funnest thing. 15 is 115. Okay, so now we're going to subtract these. Now notice, I think it would have been easier to put the bottom one up top, and you're totally allowed to do that. 15x minus 15x is 0. Negative 30y minus 20y, that's negative 50y, right? Because it's negative 30 minus 20. 15 minus 115, well, that's negative 100. Divide both sides by negative 50. Y equals positive 2. The y coordinate is 2. We can put that in any equation. I'm going to pick this one right there. 3x plus 4 times 2 is 8 equals 23. Subtract 8 from both sides. 3x, I think 23 minus 8 is 15. Divide by 3. X equals 5. And that's where they intersect, 5, 2. All right, since I eliminated x in the last one, I'm going to eliminate y here. And so I'm going to multiply the top one by 3 and the bottom one by 2. I could have multiplied by 5 and 2. So I'm going to get what? I'm going to get 6x plus 6y equals negative 18. Then I'm going to get 10x minus 6y equals 2. I'm going to add the two together. 16x plus 0 equals negative 16. Divide by 16. And x equals negative 1. I'll put that in the top. 2 times negative 1 plus 2y equals negative 6. So that's negative 2. So I'm adding 2 to both sides. 2y equals negative 4. Divide by 2. Y equals negative 2. That's where they intersect. Final question. Final question needs rearranging. So let's add 6y to both sides, and we get 2x plus 6y. And my eraser is having problems right now, so I'm just going to plus 6y equals 1, and this is 4x plus 12y equals 2. Oh, notice I only have to multiply the top one by 2. I don't have to do anything here. I don't have to multiply both of them. All right, so the top one becomes 4x plus 12y equals 2. The bottom one is still 4x plus 12y. Equals 2. So we subtract that, and we get 0 plus 0 equals 0. We got 0 equals 0. That's a true statement. So tell me about these lines. That's a true statement, right? That 0 equals 0. So that means it has a solution. In fact, it has infinite solutions. So it is not parallel. What is it? It's the same line twice. I disguised the same line twice. Right there. You can see they're the same line twice. Infinite solutions. All right, good luck with the homework.